In the previous tutorial, we discussed about the basic idea behind trigonometric ratio. We talked about the process of expressing a given positive trigonometric ratio as a trigonometric ratio of acute angle. However, in this video tutorial, we are going to focus on the process of expressing a given negative trigonometric ratio as a trigonometric ratio of acute angle. So what am I saying next is, what and what do you need to be familiar with? If you're going to recall in the previous tutorial, if you haven't checked it out, I would recommend you check it out by clicking on the video that will pop out at the top right hand corner of your mobile of this video or at the description of the video. We said on a plane surface, we have it to be divided into 4 parts, known as quadrants. We have the first, the second, third, and fourth. We said each of the trigonometric functions, sine, cosine, and tangent, have a particular sign that is assigned to them depending on each of those quadrants. For the first quadrant, we said all the functions, sine, cosine, and tangent, has a positive values. For the second, we said only sine has a positive value. For the third, we said only tan has a positive, and for the fourth, we said only cosine has a positive. Keep this in mind as we'll be using it as reference as we proceed forward. One more thing I need to add in addition. When we were dealing with examples in the previous tutorial, that's when we are given a positive ratio. For instance, sine 200. We said to form the arc, we are to move in the anti-clockwise direction, that is, in this form. And we are to start from the positive x-axis. The case is different in this case. That is when the given ratio is negative. We are not to move in the anti-clockwise direction, but in the clockwise direction. And that's just how it works. So let's analyze this concept with some few examples. Example 1. What acute angle will correspond to tan negative 55? To find out this, we need to form a plane. And here is the plane. So we know that this is 0, this will be 90, this will be 180, and this will be 270, and lastly, this will be 360 for the complete rotation. Keep in mind, if the value is positive, we have to move this way. So where 270 is with that of 90, where 180 is, will still be there, while where 90 is, will still be for 270. It's just going to flip around. So now, I'm just going to shift 55 unit along this direction. It won't reach 90 because 55 is less than 90. And after, I will draw a straight line from the origin to the end point of the arc formed. The angle between the straight line formed and the horizontal line is our main target, and that angle is theta. So whatever functions given to you, whatever trigonometric ratio given to you, will be equals to tan theta. It depends, not really tan, it depends on the given function. So tan negative 55 will be equals to tan theta. This is not really the final answer as we need to solve for theta. Similarly, we need to observe the corresponding sign of tan in the position or in the quadrant that theta falls to. So how can we determine theta? It turns out that theta will still be 55 degrees. And therefore, tan negative 55 will be equals to tan 55. Now, should it be tan 55 or negative tan 55? How can we tell? That will depend on the sign of tangent function in the quadrant that theta falls to. Theta falls to the fourth quadrant, as we can clearly see, and we know that in the fourth quadrant, only cosine is expected to be positive. So therefore, it's going to be negative tan 55. And that's just how it works. That's how to easily find the corresponding trigonometric ratio of acute angle to a given ratio. Let's consider more examples for easy understanding. So consider sine 230, typically negative 230. What acute angle will correspond to this given ratio? Just like before, let's have our plane 0, 90, 180, 270, 360. Since it is negative, I'm to move in the clockwise direction, starting from the positive x-axis. So 230 will be closer to 270, but won't reach 270. And that will be this. Now theta will be the angle between the lengths formed and the horizontal line. And that will be this. Okay, the angle between the horizontal line and the length formed. So how can we determine theta? To find theta, that will simply be equals to 230 minus 180. As we can clearly see that from 0 point of the plane to this edge, we have it to be 230. And from 0 point of the plane to this edge, we have it to be 180. If we remove that from this, we should be left over with the value of theta. And right now, theta will be equals to 50 degrees. As 230 minus 180 is in equals to 50 degrees. So therefore, sine 30 will be equals to sine 50 degrees. So should it be positive sine 50 degrees or negative sine 50 degrees? That will depend on the sign that sine possesses in the second quadrant, because theta is at the second quadrant. At the second quadrant, sine is positive. So this should be definitely a positive sign. And that's how it works. Hopefully you are following and hopefully you are grabbing that. Let's consider one example for easy understanding. By the way, if you haven't subscribed, please do subscribe to my channel. Thanks for watching. If you are enjoying the video, please kindly give the video a thumbs up so this we can recommend it to many viewers out there. Consider cosine negative 140. What acute angle will correspond to this? Having the plane being drawn, we have 0, 90, 180, 270, then 360. We have to shift 140. 140 is less than 180, so we can stop somewhere around there. So theta will be this angle. It can be this, because this is an angle between the length formed and the horizontal line. This is a vertical line. So be very careful on selecting your theta. So how can I determine theta? To determine theta, I know that from this point to this point is 180, and I got this to be 140. If I move it from 180, that should provide theta. Definitely theta will be 180 minus 140, and that should result in 40. Perfect. Which implies that cosine negative 140 is the same as cosine 40. Should it be cosine 40 or negative cosine 40? That will depend on the sign of cosine function at the quadrant that theta falls to. Theta falls to the third quadrant, and at the third quadrant, cosine is expected to be negative. So therefore, it's going to be negative cosine 40. By now, you should have been seeing the beauty behind these problems and behind the process. Hopefully, you got that and hopefully, you understand that. If you haven't subscribed, like I said, please do subscribe to my channel. Thanks for watching. See you guys in the next video. However, I have an exercise for you, and here it is. So consider finding the corresponding acute angle that to this given ratio. And that's it. Thanks for watching. Bye for now.